Papers I haven't checked yet. First of all, I'm going to just kind of scroll through the first 7 problems, so just check your answers. So everybody check your answers number 1, 2, and 3 real quick. Remember, I wanted exact and decimal. If you went ahead and converted the decimal to a fraction, because your calculator would do that automatically, that's cool. If your decimal is right, I'm sure your fraction is right. All right? Did you got it? I'm switching. Okay, check your answer number 4 and 5. Were there any questions about 1, 2, and 3? I should have asked that first. Question? Okay. All right, I'm switching. Any questions about 4 and 5? All right, make sure that if it says diameter, you go ahead and double that radius. Okay?
Do we have to put 2 decimals?
Yeah. It said nearest hundredth, so let's do 2 decimal places today. All right, here's 6 and 7. Check your answers 6 and 7. Yes. Never mind. All right, any questions on 6 and 7?
Yes. Oh my God.
All right. Question, brother?
Yeah. When you have to find the radius and diameter, when it says find the diameter.
I don't see a way to get the diameter first.
No, but I didn't write down the radius for number 7.
Well, you got to show your work, so don't skip that step. Okay. So number 8. Number 8 should be a pretty simple version of the kind of thing we were doing yesterday, where we have to ask ourselves what to do. There's 2 different strategies we could do for this, but I don't want to tell you. I want you to tell me. So who can give me a strategy for solving problem number 8?
First, find the radius.
Let's see. Yeah, by either strategy in my head, we're going to need the radius. So let's go ahead and talk about that.
28 divided by 2.
Right, Irvine knows that the radius is going to be half of this. So what's the radius, guys? So the radius is 14. Okay? Come on, y'all. I got a lot of geniuses in this class, so give me some strategies. Here's where it pays to have geniuses. Talk to me. Let's go. Okay, so one strategy that I hear Hunter alluding to is we could still go ahead and do our part over whole equals part over whole thing. So we could do this as a normal part over whole problem. I'm going to set it up, but then I'm going to see if anybody can tell me another strategy. Okay, we could set this up as part over whole equals part over whole. Hunter, what would be the degrees if we do this as a part over whole problem? Right, it's a semicircle, so if we do it as a part over whole problem, we'd be talking about 180 over 360 equals x over what's going to come down here. This is going to wind up being 196 pi. And again, I'm getting that because I'm doing area is pi r squared. Whoops. Pi r squared. And of course the radius is 14, so that's pi times 14 squared. Okay, and that's giving me that. And then I could reduce and cross multiply and all that good stuff. Now, can anybody come up with a strategy that is slightly quicker, shorter?
Reduce.
We would reduce, but that's just the next step on this strategy. I want a different approach, if anybody can think of one. Kayla, help me.
28 squared and then you divide that by 2.
Right, this is what I hear Kayla saying, I think. We had to find the area of the whole circle anyway. Even if we were going to do the part over whole method, one step of that was finding the whole area. Well, if we've got an expression for the whole area sitting there, can we just use a little bit of common sense? How much of the area is shaded? Half. Okay, so we don't really need to do part over whole. We could, but it would be a little quicker just to take the whole area of 196, right? Right, this is another strategy, okay? So the area of the whole circle is 196 pi, okay? So with that in mind, the shaded, all right, to find the shaded part, we would just take that and divide by 2. Okay, so what's 196 divided by 2? 98. Okay, so that would be a quicker way. So this would just be 98 pi. Okay, which must, well, I didn't calculate it. What would this be as a decimal? Anybody? Decimal? 307.9? 88? Right, if we do hundredths. Okay, so that's the quickest way. It's half the circle, so find the whole area and then just take half. But if you did part over whole, you should have gotten the same answer. Did you get the same answer, Hunter? Yeah. Doing the part over whole way? Okay. All right. Any questions about number 8? Quiz tomorrow. All right. Number 9. Strategies. Can anybody just talk to me in general terms about how we would approach a problem like this? Talk to me. Either one. Victoria? Wait, hold on. Go.
It tells you that the diameter of the circle by the height of it, because it's like touching both sides, so you know, like down, the diameter is 18.
We know the diameter is 18.
So you know the radius is 9, because 18 minus 9.
Okay, let me get that marked on here. Okay, Victoria is saying, look, the diameter is 18. You can tell that from the side of the rectangle. That means the radius must be half that. So the radius is going to be 9. Okay, keep going. Give me your the big picture.
And then you know the length, the top length, because it's basically like 3 radiuses lined up, circles. So you do 9 times 3, that's 27.
Okay. Look, she's saying this. Remember this diameter? 18 is basically the diameter of the circle. If I went from top to bottom, that would be 18. Well, does it make sense that if I went horizontally across, well, it guides you when you go straight. Horizontally across like that, wouldn't it make sense to you that that should also be 18? A circle should be 18 in every direction. Every diameter should be the same, whether it's vertical or horizontal. Okay, so if it's 18 up and down, it should be 18 this way. Okay, similarly, Victoria's saying, look, the radius was 9. It's half the circle. So if I do radius horizontally also, again, that's going to be 9. So we have 18 and 9 going like that. Okay, so with that in mind, tell me what you're about to tell me.
So you have the is 27.
Okay, so this side of the rectangle is 27. Wait, okay, so before you give me any more details, the numbers, I need the class to see where you're headed, why we're doing any of this. So can you tell me the big picture, what's your strategy overall?
First I would find the area of the rectangle, and then find the area of the whole circle, and divide it by 2 to get the area of the half circle. And put those together, and then subtract that from the area of the rectangle.
Okay, let me make sure if I can get people to follow the strategy. Remember yesterday when we had shapes inside of shapes? We had a heart inside of a circle, stuff like that. And we decided that we would subtract. If we wanted that outer shading area, we would subtract the bigger shape minus the shapes that are on the inside. That would leave the shaded part on the outside. So get that back in your head, the concept of taking the outer shape and subtracting. the inner shape. So that's what she's doing. She's saying the bigger shape is this rectangle. So if we find the area of the rectangle, so this shaded area, I feel like changing colors. If I did this, if I found the area of the rectangle, in fact, I'll do it in symbols. And then I could subtract the area of the circle, and I could also subtract the area of the semicircle. Okay? It's not a very good semicircle, but hopefully you understand what I'm saying. So if I take the whole big rectangle, subtract the circle, subtract the semicircle, that should be the shaded area. That's her strategy. Okay? So along those lines, she found these numbers. She's getting ready to find the area of this rectangle. In fact, let me kind of divide this up a little bit. Okay, so over here we're finding the area of a rectangle. Okay, how do we find, all right, let me jump to some other people now that Victoria got us started. Jesus, you don't know? Base times height, that's right. And if you forget, it's right here. Yeah, area of a parallelogram or rectangle, base times height, okay? So in this case, what's the base and what's the height?
Base 27.
Base 27, height 9. Okay, so we're doing base times height. Oh, not 9. 9 is only halfway. Remember, the height is like this one over here. So 27 times 18. 486? Okay, so that's the area of the rectangle. Okay. Of course, we find the area of the circle by doing pi radius squared. Okay, the radius is 9. So can you give me an expression for the area of the circle? 81 pi. Okay, that's the area of the whole circle. So of course the semicircle over here, how am I going to find that?
Divide by 2.
Just divide by 2. It's going to be half. So this should be 81 pi divided by 2. All right? Do you understand that last one? Margaret, did it make sense to you where I got this 81 pi over 2 from for the semicircle? Put it there. ¿Entendiste? Okay. ¿Entendiste esto? Okay. ¿Entendiste que we're going to empieza con rectángulo y resta? Okay. You understand all that part. So this part, so I had the rectangle. And do you understand the rectangle part? So I'm going to subtract the circle and then the half circle. Okay? So this part in the middle, that's this. That's the circle. Okay? That I'm going to subtract. Area of a circle is pi r squared. Right? So this circle, what's r? 9. Okay? So that's why I took 9. And I put it in for r. Okay, that's how I got the 81, because 9 squared. Okay, so that's the word 81 pi. So that's the whole circle. So then the half circle is just la mitad, so over 2. That makes sense? Okay, is everybody with me now? Anybody lost? Okay, so we said that to find the shaded area, we were just going to do the rectangle minus the circle minus the semicircle. So that's what we'll do. Let's see, all right, so what was it? 486 minus 81 pi minus 81 pi over 2. Okay, 104.3. Even rounded to the nearest hundredth, that's what we're going to get. Okay, so that's going to equal 104.3. Okay, any questions? On number 9. Quiz is tomorrow. These are typical quiz questions. All right, look at number 10. Margaret, can you just give me the overall strategy of how we're going to approach number 10?
You subtract the area of the square from the circle.
Right, the overall strategy is going to be find the area of the circle, because that's the bigger shape, and then subtract the area of the square. Okay? So let's set that up. So we're gonna find the area of the circle, and then minus the area of the square. That's our strategy. Okay? So the area of the circle, of course, is pi r squared. Okay, Burton. Can you do this in your head and tell me what the area of the circle is?
Area of the circle. It's pi squared.
And what is 8 squared?
64.
Okay, so we have pi times 8 squared. So that is 64 pi. Okay, that's the area of the circle. Now we need to find the area of the square. How do I find the area of a square? It's just like a rectangle. We're going to need base times height. So we need the sides. Okay? Now this is slightly tricky, so I'll go ahead and write down that we need base times height. We don't know the base and height right this second. So we need to find it. All we've got is this 8. All right, but let me stretch this out. Obviously, if this is 8, what's the length of this entire side of the triangle? Okay, this side of the triangle must be 16. Now, if you're not comfortable with your special triangle knowledge that we used to do last semester, okay, remember this, how the hypotenuse was always leg radical 2? If you're comfortable with that, that's the quickest. So I'm going to do that first. Hypotenuse is x radical 2. Okay, keep your eye on that. X radical 2 is the hypotenuse. That means this 16 must equal leg radical 2. This is how we used to do it. Okay, so India, you understand that the hypotenuse is 16. Okay, you understand that this is a 45-degree triangle. I should mention that. All right, when you cut a square, it's 45 degrees. So we can use our 45-45 triangle knowledge. On a 45-degree triangle, the hypotenuse is always leg radical 2, like x radical 2. So since I've got a 16 in the position of x radical 2, I can set those equal to each other. X radical 2 must equal 16. They're both hypotenuse. No, definitely, because 16 is not the side. We need to find the sides, not the diagonal won't help us. So I could solve this little equation by dividing both sides by radical 2 real quick. Okay, so divide by radical 2, divide by radical 2. Okay, if I do that, I'm going to get x equals 8 radical 2. Okay? That's the leg. That's the side of the triangle. All right? That tells me that this is 8 radical 2. And since it's a square, that means this is also 8 radical 2. Okay? So when I go to do base times height, that means I will have 8 radical 2 times 8 radical 2. Okay? Okay, that's 128. All right, so the area of the square is 128. So our strategy was take the circle, subtract the rectangle. So 64 pi minus 128. Okay, 73.1. Okay, so that's how you could do it. Any questions right there? Okay, we still have time. All right, moving on. Number 11. Anybody? Can anybody give me the strategy? Well, anybody besides Victoria, 'cause she already gave me a strategy, so I know she's got this. Can anybody else give me a strategy, just the overall picture? Go ahead. Talk to me. No, I haven't spoken to you today, so yes.
Since the side's 48, if you do another line below it, that's going to be 48 too.
Mm-hmm.
Then you divide it by 4, so it's...
Wait, before you give me any more details, tell me why. Like, tell me where you're headed. What's your strategy?
The area of one circle, then multiply it by 16 and subtract that square.
Okay. Listen to his strategy, because if you understand the big picture, actually doing it is not very hard. But you need to understand we're just like we did before, we're taking the big shape and we're subtracting the shapes on the inside. So we're taking the square and we're subtracting all of the circles, all 16 of them. Okay? So his strategy is let's do the area of the square minus the area of all these circles. I'm not going to draw them all, but this is the idea. Okay? His strategy is to take the area of the square and subtract the areas of all the tiny little circles. Of course, to find the areas of all the tiny little circles, he's going to start by finding the area of one circle and then multiplying that by 16. We'll find one. There's 16 of them, so we'll just multiply. Okay? So let's do David's strategy. Okay? First of all, the area of the square. Square is 48, so we got to do base times height. Okay? So that's just 48 times 48. What is that? 2,304. Okay. Now, for this little circles, we need to start with one circle. Okay. One circle. We need to know the radius. Okay, so, David, we have 48. So, that's 1, 2, 3, 4 of those. Okay, so how much are these diameters going to be? Kayla, get out of that backpack. 48 divided by 4? Okay, so for starters, these are all diameters of 12. I got it, I know. Those are all diameters 12. That means the radius of each one of these circles is 6. That means one circle is going to be 36 pi. That means 16 circles. Do not pack up, children. You know better. Do not test me. I'm not playing with that. 16 circles will just be 36 pi times 16. What's that? 576 pi. All right, and then you would just subtract. So this minus that, and what's the answer? 494? All right, pack up.
Wait, where did you get the 576?
The one circle times 16.